is especially pronounced on the northeast or left side of its major axis. Such galactic warps are very difficult to demonstrate conclusively because the outer portions of a spiral disk are extremely faint compared to their bright central regions. However, the warp in Andromeda may be the most extreme case of a warped spiral galaxy found thus far. Possible causes of the warp include interactions between Andromeda and its smaller satellite galaxies. On October 18, 2006, astronomers using NASA's Spitzer Space Telescope announced the discovery of two dust rings or holes in Andromeda's dust disk using infrared light that provide evidence of an ancient head-on collision with a neighboring dwarf galaxy along its polar axis, Messier 32 or M32, some 210 million years ago. Computer simulations support the hypothesis that the passage of the much smaller galaxy created violent waves of gravitational interactions that left rings of gas and dust propagating outward from the site of the impact. Since Andromeda is much more massive than M32, the larger galaxy was not substantially disrupted, but M32 lost more than half its initial mass in the course of the collision. On September 16, 2009, NASA's SWIFT satellite mission released the highest resolution ultraviolet image of Andromeda available, covering an area of some 200,000 light years wide and 100,000 light years high. The image was compiled from 330 ultraviolet images made at wavelengths of 192.8, 224.6, and 260 nanometers. The result covers some 20,000 ultraviolet sources among the hottest and youngest stars and stellar remnants in Andromeda's spiral arms, densest clusters, and violent core around its central supermassive black hole. On January 5, 2011, the European Space Agency released a composite far-infrared and X-ray composite image of the Andromeda Galaxy. The composite used images taken by the Herschel and XMM Newton space telescopes. It highlights the rich gas clouds where new stars are being born in Andromeda's spiral disk and where stars have likely expired as white dwarfs or in the supernovae and become neutron stars or black holes, including Andromeda's supermassive central black hole. Many in bright X-ray binary systems where gas and companion stars generate X-rays as it falls onto their companion stellar remnants. In the 1990s, astronomers using the Hubble Space Telescope found Subsequent ground-based observations led some astronomers to speculate that two galactic nuclei do indeed exist, are moving with respect to each other, and that one nucleus is slowly disrupting the other through tidal forces. As a result, some astronomers believed that the one nucleus that may be the remains of a smaller satellite galaxy was eaten by Andromeda. In 2005, astronomers using the Hubble Space Telescope announced that the two bright blobs are actually composed of an elliptical ring of older red stars and a smaller, brighter, and denser disk of young blue stars of around 200 million years old around the galaxy's central black hole. Andromeda's core has a supermassive central black hole of around 140 million solar masses. Recent observations with the Chandra X-ray Observatory also reveal numerous other bright X-ray sources, most of which are probably due to binary systems where a star is feeding gas into a neutron star and black hole. A very cool X-ray source has been identified about 10 light years south of the galactic center. A second, hotter X-ray source was found to be at a position consistent with the position of the supermassive black hole. Andromeda's satellite galaxies include M32 and M110, two bright dwarf elliptical galaxies that are the brightest of a swarm of smaller companions. By late 1999, however, at least 10 satellite galaxies of Andromeda were known, including NGC 185, which was discovered by William Herschel, and NGC 147, discovered by Heinrich Ludwig der Rest, 1822 to 1875, as well as the very faint dwarf systems, and 1 and 2 and 3, and possibly and 4, which may be a cluster or a remote background galaxy, and 5 and 6, also called the Pegasus dwarf, and 7, also called the Cassiopeia dwarf. All of those ands, and 1 through and 7, are Andromeda 1 through 7. Satellite galaxy M32 may be interacting to distort the disk structure of Andromeda itself, whose spiral arms of neutral hydrogen are displaced from those consisted of stars by around 4,000 light years, and so cannot be continuously followed in the area closest to its smaller companion neighbor. Computer simulations have shown that such disturbances can be modeled by assuming a recent close encounter with a small companion of the mass of M32, which also suggests that M32 lost many stars from such an encounter to be spread out in Andromeda's